So today we're going to continue on with a little bit of pre-calculus stuff, talk about functions and their graphs. Hopefully most of this stuff is review. If it's not, then by going over it, maybe it'll click for you and you'll be back to where you were in pre-calc. So list of objectives today. We're going to talk about functions. What is function notation? What is a function? We're going to talk about domain and range. Domain, x values, range, y values. You know that already. We're going to talk about graphing functions. We're not going to spend a lot of time on graphing, but what we are going to spend a lot of time talking about is transformations. So not necessarily how to graph big complicated functions, but how to take the mother functions and slide those around, flip them over to get, we did a little bit of that 2 days ago. Okay. Using the mother functions, I just mentioned that. We're going to work with composite functions, putting one function inside of another function. The tricky part for most students is remembering, does f of g mean you put g into f or f into g? And then we're going to spend a good chunk of time solving polynomial inequalities. And not because solving polynomial inequalities is such a crucial topic for us, but because there's a lot of things that you use solving polynomial inequalities that apply to the stuff that we're going to do in calculus. Now we're going to talk about piecewise functions. How to take chunks of a graph and put them together into one big graph while maintaining the fact that it's still a function. We might talk about the step function. I might put that off for a little while because we're going to have a lot of other stuff to do. Okay, so there's a lot going on this screen. I just wanted to throw this up there to refresh your memory. Domain is all the possible x values. Range is all the possible y values. More importantly, at the bottom, when we're talking about independent variable versus dependent variable. Okay. So if you think of a simple equation like y equals 2x minus 5, one of them is independent. The x value is the independent value. So you're going to plug a number in for x, whatever number you want, and it's going to spit out a value for y. That value for y is dependent, hence the name, on the value that you plug in for x. And again, you should know that, but just wanted to refresh your memory. You will see a lot of these blue boxes in my slideshows. I pretty much just took those right out of the book. And a lot of it is what I call calculus speak. Calculus speak is they like to take something very simple and make it very verbose. And the only reason I include it is because occasionally they will mention terms that we need to talk about, or they'll use some notation that we need to talk about. Okay. But you know, domain is x, range is y, dependent and independent variables. Okay, so just to change things up a little bit so I'm not talking for 70 minutes straight, we're going to do some breakout rooms. So on your on Schoology, there is in the Chapter 0 folder, there is a document called Breakout Session, or Breakout 3, Day 3 Breakout Examples. If you could download that, fire it up on Notability, and I'm going to put you in some random breakout rooms and then solve this. Now, before you go to the breakout rooms, I wanted to mention, in case I forget, I will unlock, or I think I already have unlocked, another Google form called Info and Groups. I had this big grandiose plan where you were going to interview different people in the class, and we just don't have the time to do it. However, I have a feeling that you know enough people in the class to fill out that Google form. By Tuesday of next week, I would like to have some semi-permanent groups set up. Part of your homework ideally I'd like you to do it today, would be to fill out that information thing. Number one, it gives me some more information about you so I can try to learn a little bit more about you. And number two, it allows you to tell me who do you want to be in a group with. Okay, does all of that make sense? Give me a vocal yes.
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 Yeah.
Beautiful.
Yes.
Okay, so jump on to Schoology, do that. I'm going to put you in your random breakout rooms for today, and then hopefully by Monday we will have some semi-permanent breakout rooms. Look at you guys, you overachievers. You knocked those out already?
Yeah.
Including the last one?
Yeah.
Nice. All right, cool. We're going to give the rest of them one more minute. Enough slacking. All right, so everybody should be back now, yes? We're good? Beautiful. Okay, before we talk about the answers, let's talk about what does it mean. So, for instance, what does f of 3 mean? What is that asking you to do?
Plug in 3 into the equation.
Beautiful. So you should get 16, yes? Okay. What's f of smiley face? Don't be bashful. Unmute and answer me, because remember, I can't see you.
Smiley face squared plus 7.
Perfect. Take whatever's in parentheses, plug it into the function. b minus 1 quantity squared plus 7. Okay. Quick refresher here. This is not b squared plus 1. It's b squared. Square the first term, multiply the two terms together and double it. Square the last term. Okay, b squared minus 2b, or not 2b, that is the question. No? All right. Plus 8. Okay, that's all fun. That's basically Algebra 1 stuff, maybe? Algebra 2. I don't know if Algebra 1 they actually do function notation. But Part C is a big deal for us. You may have seen this in pre-calc. If you haven't, well, when you saw it in pre-calc, you're wondering, why the heck am I doing this? This is the foundation for what we're going to do in calculus for about 2 months. It's really important. So I want to work this through with you so that you understand the plugging and chugging is one part of it, the simplifying of it is another part. So f of x plus delta x means go to the function, wherever you see an x, put in x plus delta x. X plus delta x quantity squared plus 7 minus. Now, I didn't include it in the original problem, but there should be brackets around that. And that bracket is incredibly important for what we're going to do in the future. The reason being is because that minus sign is there. Without the brackets, you'll forget to distribute the minus sign. Okay. So that's step 1. Do you understand the concept of the notation to plug into the function? Step 2 is being able to simplify that. X squared plus 2x delta x plus delta x squared plus 7 minus x squared minus 7. That's important. Okay, x squared and negative x squareds go away. 7 and negative 7 go away. That makes me happy. Why does that make me happy? Well, if I take the numerator now and I factor out a delta x, I can then cancel, and I get 2x plus delta x. Okay, that's my final answer. That's the first part of something we call taking a derivative, which we'll get to later. Okay. If you don't get things to cancel out, you did something wrong. Every time you use this, what's called the difference quotient, you should get some things to cancel in the numerator. Alrighty? Beautiful. Let's move on. Domain and range. Okay. If I give you a picture of any function, hopefully at this stage you should be able to tell me what the domain and range is. Where it becomes more difficult is when I don't give you a picture. Okay. So for instance, in this class, unlike I think it was advanced algebra where you dealt with imaginary numbers and all that other fun stuff, we don't do any of this. It's a real number foundation, so no i's ever show up in this class. But there are two things we're concerned about with domain. Never have a zero denominator and never have a negative square root. Unlike advanced algebra, where you would then say, oh, I've got the square root of -4, then that's 2i, or plus or minus, and do you want all that garbage? I means nothing to us in this class. If one of these two things show up, it's bad. You either made a mistake or there's no solution. Okay. So in this particular problem, what's the domain? Now you can answer that question two ways. You can answer the question as, what can x be, or what can't x be? Feel free to answer either way. Give it to me.
X can't be 2.
Or?
-2.
Beautiful. Okay, so how do you want to answer that? Well, you could do just that. X cannot be plus or minus 2. That's the easiest way to answer. However, they, being the College Board, will make your life more difficult and say, oh, no, we want this in interval notation. So you would have to do something like that. Okay, those are the possible x values. -infinity to -2, union -2 to 2, union 2 to infinity. And notice they're all parentheses. Parentheses versus brackets. Brackets inclusive, parentheses non-inclusive. So this is saying I want all those numbers to the left of -2. I'm going to skip -2. I want all the numbers between -2 and 2. Skip 2. I want all the numbers to the right of 2, which is what this says. Unless it specifically says give your answer in interval notation, answer in the easiest form possible. If you find this easier, then use that. But you should also, in case you've forgotten about it, you want to refresh your memory on interval notation. Okay, so we have a function here. Now, there's a couple different ways we can do this. We can start looking at this algebraically and plugging in numbers and testing things. I'm a visual learner. I like pictures. So I would think about what that graph looks like and answer the domain and range that way. So let me ask you that question. What does that graph look like? First of all, what mother function is it based off of?
Square root of x.
Square root of x. Beautiful. And hopefully you know what the square root of x looks like. What does the -1 do to the square root of x on the graph? Does it go left or right?
Right?
It goes to the right, so we get that picture. If I can do that graph, then the domain and range is a simple question. Okay. What possible x values do I have there? In interval notation, I would go 1 inclusive up to infinity. Remember, infinity is never a bracket. It's always a parentheses. Okay, so there's the domain. What's the range? Oh, let's make things saucy. Ben, what's the range?
What's up?
What's the range?
Oh man, it's infinite. It's 0 to infinity.
inclusive for 0 or no?
Yes.
Yes, very good. Okay, we're done. Okay. Now, what if it's not a picture that what if it's not a function that you can easily graph? Well, then you got to take an algebraic approach to this. And this is a very simple problem, but what does the algebraic approach look like in this problem? I would have to take x minus 1 and make it greater than or equal to 0 and solve that inequality to find the domain, and then the range is even more complicated. So I like to default to a picture if at all possible. As I mentioned when we were talking about the objectives of this thing, I don't want to beat a dead horse by spending tons of time graphing. I do, however, well, before we do the piecewise, I do want to make sure that you can do what we just did in this problem with most, if not all, of the mother functions. So you can take the square root of x and manipulate it, flip it over, slide it left and right, slide it up and down. You can take the absolute value function like we did yesterday on the homework, slide it up and down, flip it over, and again, know the order that you're supposed to do that. Okay. The exception to that would be graphing piecewise functions. The most common mistake I find with piecewise functions is people forget this important word. When you're done with your piecewise function, it still has to be a function. Okay. So the question is, how can you tell if a graph is a function?
Draw a line through it.
Yes. Explain more, Marcus. What kind of line?
Draw a vertical line through it, and if it intersects twice, it's not.
Perfect. Vertical line test. Test whether or not a function is, or whether or not a graph is a function. So when you're done with this piecewise function, you want to give it the vertical line test. If it doesn't pass the vertical line test, you did something wrong. Okay? And you'll also notice in red, don't forget to emphasize open circles and solid dots. So what's going to happen is people just want to grab their calculator. You're going to graph all 3 of those functions on your calculator and try to slap them onto this ugly graph. There are spots where it starts and stops. Those starts and stops should also be determined by solid dots and open circles. Okay? Get into your groups. I think I'll create some new groups now and solve this or graph this piecewise function. Again, when you're done, check to make sure it is a function. Bye-bye. Hi, guys. Yeah, come on in. The video's off. I'm muted, so you're good.
It's too hot.
It gets pretty hot. I mean, it was hot when I walked in this morning. It'll get hotter in the afternoon when the sun comes in. But I mean, I hate to complain because I know you guys got 10,000 things going on. But when I came in this morning, it was already hot, so I had to open the window. It helped a little bit, but
No.
Did that happen today?
This is
But not what yesterday or the day before?
it's
What?
been hot for probably 3 days.
Okay.
Yesterday was the worst, though.
no. This is not complaint. This is help. This help us.
Yeah, but
Thank you.
but I know you guys got it.
No, thank you.
I'm muted. Yeah, I know you guys got a shit ton of stuff to do. So I'm Mike, by the way.
Yeah, hi, Mike. I'm George.
I
know Marco.
I know Marco. Everybody calls me Reedy, so
Okay. Hi. How are you?
if you call me Mike, I probably won't respond. But just so you know, I appreciate you responding to the email.
No
too.
problem. Thank you.
Yeah, and I understand that people are complaining that their rooms are too cold and their ice boxes,
Yes.
and so I was hesitant to send the email, but
No, please. This help us because that way Marco can see it tomorrow.
awesome.
No, this is up to you. This is up to you. This is this one's in 17. No, I think I this game.
You see? If you cannot be yourself, be Batman.
I was Spider-Man. I was Spider-Man.
Thanks, guys. Have a great weekend.
Thank you. Bye.
Everybody's back by now. Beautiful. Okay. Before I forget, one thing I forgot to mention. If you go by a different name than what it says on your attendance or official documents, change your Zoom name, please, so that I can, because basically all I get is a small picture of you and your name there. So I'd like to be able to call you by the name that you want to be called by. So find out sometime when you can jump into Zoom preferences and change that to the name you prefer. Okay, so let's graph this puppy. Normally, if we had a little bit more time or things were going a little bit smoother, not that they're going smooth, but you understand, I would have somebody else show their screen, but I'm just going to jump on this right away. There's a couple different ways you can do this. I like to attack it as a big picture thing and then erase stuff. You can work however you'd like. So for instance, I'm going to go right to the middle and talk about x squared because I know what x squared looks like. And I know that at 0, 0, which is where x squared starts, it's going to be a solid dot. How do I know it's a solid dot?
Because it's less than or equal to.
Beautiful. That guy right there. And I know it's going to end at 2 with an open circle. And 2 squared is 4. So 2, 1, 2, 3, 4. Open circle. And then I do my little parabola. Okay? That takes care of that puppy. Now, let's do the other easy one. 1, if x is greater than or equal to 2. Well, that's going to be a vertical line. Sorry, I lied. Horizontal line. And put arrows on there. I put an arrow on there because it goes on forever. Okay. Now we'll do the last one. And the last one is a line. It's going to go from 0 to negative infinity. So I know that at 0, I'm going to have a value of 3. It's going to be an open circle. And it has a slope of 2. So rise over run would put this other dot here, so I would get something that looks like, whoops. It's not perfect, but it'll work. And then step back for 2 seconds and say to myself, self, is that a function? Does this thing pass the vertical line test? Yes or no? Yeah. No matter where I draw a vertical line, I'm not going to hit the graph in more than one spot, which is why these open circles and solid dots are so important. If, for instance, I screwed up and I made this a solid dot, now all of a sudden it's no longer a function because the vertical line through 2 would hit the graph in 2 spots. Okay, so again, when doing piecewise functions, make sure you stress open circle or solid dot. And unfortunately, if you rely on your calculator too much, it won't show you those open dots and solid dots and open circles. Okay. Questions on the piecewise? Anybody have any problems? Again, you need to speak if you can, or if you do have questions, I mean. Okay, good. Transformations. We've done this already. I'm going to go through this quickly, but the transformations is what allows us to move these functions all over the place. Quick question on the last part of the breakout room or worksheet examples. I'm going to send you in there. Quick, maybe 2 minutes, and then I'm going to pull you back in here. Take a look at that next problem. Go. Okay, everybody's back. Quick question. Are you guys actually talking to each other in breakout sessions? Because I haven't jumped into any. Or are you just going into a room with 3 other people and working by yourself?
Talking.
We're talking.
All right.
Yeah, we're talking.
Beautiful. All right. I don't have the problems up here, but very quickly, part A, it's the mother function of x squared that's shifted up 4. In part B, it's the mother function of x squared that's shifted to the right 4 because the negative 4 is inside the function. In part C, it's the square root the squared function that's flipped over the x-axis. Let's talk about this last one though. We've got a +3, a +1, and a minus sign. What does the minus sign do first?
Flip it.
Flip it. What's the +3 do? Left or right?
Left.
Left. And what's the +1 do?
Up 1.
Okay, good. Which one happens first?
Left 3.
No. Oh, yes. No, I'm sorry. You're correct. Left 3. Please excuse my dear Aunt Sally. Parentheses first. Left 3. Then what?
Then it opens down.
Yep. Flip and then the up one. Okay. Good. All right. That business is all summarized on this page. Okay. And if you don't know this or you want to get this, number 1, it's in the book, or number 2, you can come back to the slideshow and get it later because I want to move on to composite functions. I'm going to pick up the pace a little bit because I'm not going to be able to get through everything, and I want to give you at least an exposure to some of these things in the next 10 minutes. All right, composite functions, putting one function into the other. Notice the notation up here. F of g of x means take g of x, put it into f. Okay. You will see a flip back and forth between the two. So for instance, in part A, it's saying what is, where's my pen? There it is. What is f of g of x? That means take g, which is the cosine, and put it into there. We get 2 times the cosine of x minus 3. Simple. And then part B, a g of f of x, put f into g. We get the cosine of the quantity, 2x minus 3. And this should be pretty easy for you, I think. Yes? Give me a thumbs up. I can see some of you. Good enough. I don't want to beat a dead horse. We are good to go there. Now we get into the fun stuff. Polynomial inequalities. Okay. Solving a polynomial inequality. You're going to have to test regions at some point in time. And this will start coming back to you as I work through it. Does the term Boolean logic mean anything to anybody? Your pre-calc teachers did not show you that. Okay, so take out your calculators, please. And unfortunately, I don't have a way to display my calculator, so I'm going to have to talk you through this. On your home screen, type 2 store x and hit enter. The store button is on the left side towards the bottom. 2 store x. So it should have displayed 2. Now, no matter what you do with the calculator, from this point on, it's going to consider x to be 2. So on the home screen again, type 3x plus 1 equals, now equals, hold on, I gotta grab my calculator. The equals sign is under the math menu. Whoops. Sorry, I have my clicker in my hand. Is under the math menu. Sorry, I lied. It's in the test menu, which is above math. And it's at the very top. And then set it equal to 10.
Wait, can you say again where the equal button is?
See the math button over on the left-hand side? Above the math button is test, so it's second math.
All right, thank you.
Okay. So now you have an equation on your home screen. When you hit enter, it's going to give you a 0 or a 1. It doesn't matter what you do, you're going to get a 0 or a 1. The thing you need to remember if you're going to use this is 0 is false, 1 is true. So yours should have displayed 0 because we have a false statement. because x is 2. Does that make sense? Now, this seems more complicated than it has to be, and most of the time you probably wouldn't use the Boolean logic, but I want to give it to you so that when things get ugly, you have an opportunity, or you have another tool for you to work with. Okay, so we're going to do this puppy. We're going to start with something simple. Nice, easy, quadratic inequality. Step 1, make an equation. So turn the inequality into an equation. Step 2, big jump there. I solved that and found the answers. These, by the way, are called critical numbers. Critical numbers are very, very important in calculus, which is why I'm spending some time on this. So if this was an equation of just a simple quadratic, x squared minus 3x minus 10 equals 0, we'd have two answers, 5 and negative 2. But it's not an equation, it's an inequality. So then we have to put those critical numbers on a number line and test regions. You're testing to see if numbers in that region are true or false. You're not plugging in the critical numbers, you're picking whatever number you want. Okay, so I did that already. Now, what would this look like? Well, first of all, what I neglected to do is I would include an open circle here and an open circle here. Why are those open circles?
Because it's greater than, not just like greater than or equal to.
Bingo. And when you test regions, you're just going to pick a number in the region. What's a good number to pick in here?
0.
0. If I plug 0 in there, I get 0 minus 10 is negative 10. Is negative 10 greater than 0? No, it's false. No good. Pick a number over here. You can pick any number you want as long as it's bigger than 5. Put in a gabillion. A gabillion squared minus 10 is a big honking number. That's going to be bigger than 3 times a gabillion. It's true. Put in a very negative number, something more reasonable like negative 14. You're also going to get a true statement. So this is a graphic representation of where your possible answers are. Then you need to take that and write it in interval notation. Okay, whoops, I didn't do that. Negative infinity, again, always a parentheses, comma, negative 2, parentheses, because it's an open circle, union 5 to infinity. Everything's a parentheses there because everything's open circle. Okay? Does this look familiar? You remember doing this? Yes or no? Yeah? Okay. Now, things get a little bit more complicated on my second example. Before I even dive into this problem, what must I be concerned about? Any takers?
Common denominator?
Nope.
X can equal 5
Or that other one. Negative 3 halves.
Yeah.
Good. Why? I don't know who's answering. Why?
Because then the denominator would equal 0.
Good. Remember way back when we said the two things we care about in this class are no zero denominators, no negative square roots. So regardless of what happens from this point on, I need to keep this stuff in the box in my head because that's going to become relevant when we start graphing on a number line. Okay. Now, how do we solve that? So obviously step 1, set it equal. So turn it into an equation. Now, some person already mentioned, I don't know who it was, but somebody said common denominator. I wouldn't do it that way. How would you do it?
Cross multiply.
Cross multiply. 2 times 2x plus 3 is equal to 2 times x minus 5. Okay, I'm going to stop there. Nice, easy linear equation. You can go through and solve that. You'd get an answer. Then when you put numbers on the number line, these numbers that I think it was Manda that helped me earlier, are also critical numbers. But regardless of what this sign says, these are always open circles without an exception. Okay? Beautiful. If I had more time, we'd go to breakout rooms and solve this. We didn't, so let's move on.